much more easily when you have approximately the right y-intercept. Now play around with it to get a good trend line on there. There you go. Yeah, you need to change the y-intercept. So get your, hold up. No, what are you doing? Remember, you're changing the y-intercept, not the x-intercept. No, keep scrolling to the left. Keep going to the left. Look at your, stop right now. Look at your equation. What's the y-intercept right now? No. The y-intercept right there.
29.8.
Yeah, you want a negative 29.8? No. Keep going to the left until you have a y-intercept that makes sense for that data. I would always get my y-intercept approximate first, and then I might get into the slope. Or then I would get into the slope. Every day, man.
I mean, we take that at lunch. And I always drink a lot of water before we go out there and pray.
I'm telling you. You got a good one, Hobson?
Sure.
Okay. Here, go quickly. We're about to move on to the, actually, hold on until we get started on the next part, because we're about to get started. So let's look at each of these. I am aware. So let's look here. So first one, y'all agree? Pretty good trend line?
Yeah.
Yeah, that works. Again, is it showing that trend in data? Yeah. Approximately. What about this one? Yeah, could this one be a little bit better? Khalil, you looking up here? What could we change? Why might I ask you to change this one just a little bit? It's okay.
No, you can like bump it up just a bit.
Okay, notice down here where it's a little off.
Yeah.
I want to show those data points pretty well. And once I bump it up, I might have to rotate it some more, but that's something I would consider. What about this one? Looks like one of us needs to change our slope again. Now, I want you to notice, will this symbol change our slope? No, the y-intercept's fine. We don't want to change that. You need to move that cross to one of the ends to change the slope. So hit escape. Khalil, is this one yours? No? No, man. Yes, it is. Hit escape right now for me, Khalil. Because you see how you have this symbol? That was changing the y-intercept. Move your cursor to the end. There you go. Now, you see how that's allowing you to change the slope? Your y-intercept will stay the same. Now, change your slope to get to those data points. Okay? Alright. So let's get back to the questions on the task. So you should each have a different linear model. Write the equation for your linear model right here. Write the equation for that linear model right there. Come on, Cam. Come on, Cam. Golly. Now Chase awake and doing stuff, helping Hobson out, and now Cam's out. Can't catch a break to teach. He should have known. He's got stuff to learn. This next part's important. Dude, literally it's just write down the equation. I know, but write the equation in that space. Yeah, right there. Alright, so Chase, what'd you write for your linear model?
F of x equals 0.073 divided by 0.0.
Alright, does anybody want to push back on anything there, or are we good with that being an appropriate equation? Huh?
Oh, I put 0.03x.
Okay, so we do need the x there? Yeah, we do definitely need that x, right? Because remember, this was the equation of a linear function, right? So y equals mx plus b, right? M and x are being multiplied because multiplication is what? Repeated addition, we got that additive rate of change in there. Okay, now, I want to talk about two things here before we move to the rest of this. First off, why are we calling this a linear model? Okay, but why not just call it a linear function then?
Oh.
Break it down. Linear, what does that mean? It's a line. Model, what does that mean? Showing something, come on, let's think of some other words.
Representation.
Ah, a model is something that's representing something else, right? Specifically, what are we trying to represent with this? Ish. It's something to do with that, I would agree. But in general, we're trying to represent.
Bridges.
It starts with a D. It's a type of point.
Main.
So the word is up there if you look. Data points, thank you. Please note, when we're talking about models here, right, we're talking about representation, right? A representation of data. Now there's other types of models in mathematics, but specifically this linear model is, we say linear, so it's the shape of a line, right? So linear model, right? So it's a model, which notice we've defined model up here, in the shape of a line. I would write that down because I have not finished creating the big idea graphic organizer. However, that term linear model will definitely be on that big idea graphic organizer. So please note I did some shorthand there, right? But I'm pointing out that a model in general represents that data. And so this linear model is a model in the shape of a line. So could we have a quadratic model? Could we have an exponential model? As long as it's representing data in that shape, right? Now, we only have 5 in here. So I'm not going to ask you to do this in sets of 2. I want you all to talk as a small group, without me jumping in. I want you to talk about what you think that the input variable represents and what does the output variable represent. I'm going to listen in, and at certain points I might jump in, but I want you all to come up with what you think the answers to these might be. Now, if I were you, I might either write really small and just write a note to myself that this is just sketching out my ideas, or if you don't want to have to erase anything or write super small, you could write on the desk, sketch out your ideas, and then put your our final discussion on the paper. So maybe get a marker or a separate sheet of paper or something to write some sketching of ideas out.
The answer is C and the output is input is C, what?
Input is feet, and the output is temperature?
Yeah.
Okay. I've heard you make a claim. What's your evidence? Don't forget.
Temperature.
What's the evidence, though, that you think the feet is the input and the temperature is the output? We need the whole class in this conversation.
The X is the input.
Is that something we can all agree on? The X is the input?
Yeah.
Yeah?
F of X.
F of X? Oh, that's a good point, right? So I might even note that off to the side, that F of X, right? The X is the input. That might be an important thing to notice here. Come on, keep it talking. Let's go. Hobson, you agree?
Yeah, man.
Okay.
I'm trying to stale, man.
Well, I'm trying to get you to learn too.
I ain't going to like him.
I appreciate that. You're doing so well earlier. Okay. But here, so we all agree that input is X, output is Y, but like, I want you to notice the question says, what does the input variable represent? And Eric was talking about this earlier. He was talking about the feet and the temperature, I believe. We might want a little bit more context to it, which is why we might be want to sketch, huh?
Degrees Fahrenheit.
Okay, so that's referring to the what?
Temps.
Okay, so in general, we're gonna talk about temperatures, degrees Fahrenheit. Chase, do you agree with that?
Sure.
Sure, Mr. Kenny, I haven't thought about it. Didn't listen when Eric was talking about it. Sure, I'll agree.
Temperature of heat, I looked at the bottom of the calculator,
Ooh, say that one more time.
right here.
You looked at the bottom of the calculator?
It show you right there.
It shows you right there? Can someone write on the board what you see at the bottom of the calculator that's telling you what's going on?
Sure, I got it.
Thank you, sir. Right?
You go Chase?
Sorry. So don't write this right where Chase is writing on your paper, but,
Y'all can, if y'all want to.
well, no, I'm just saying don't put it on your paper yet. But notice on the calculator, it literally says temp, comma, feet, right? So I want you to notice, temperature is in the place of which variable? The x. So what? You have it backwards? So the temperature,
Is the input.
say that one more time.
So temperature is the input.
Temperature is the, say it louder.
Input.
Input, what do y'all think about that? Temperature is input?
Sure, Mr. Kenny.
Sure, Mr. Kenny, I didn't want to think about it, so I'll just agree with what it
Do
says.
you have in your classroom any juniors or seniors that played varsity football? Juniors or seniors that played varsity football? Please have those children report to the library momentarily. Thank you.
Yes. Alright, well, we're gonna chill for the next however long until they come back.
They ain't played you though.
Oh, that they played.
Yeah.
I played, no, that don't count, bro.
I don't think that counts.
No, they ain't played.
It does say played. Let's do this.
Played or played?
Eric, can you run down there real quick and check to see if they want you down there too? We'll put a pause.
So they said seniors too.
Well, but they did say the language was played, as in they already played one.
Send them a text? Yeah.
Yes, that's fine.
I do.
Mr. Kenny, I need to take a picture of this dude right now.
Hold on, wait.
Right, like his lips all up on the calculator and everything.
How big you come in?
Take a picture. I never took a picture of it. Oh, that's a good question. Let's ask Richie. Hey, Richie. Okay.
Everybody that's shooting.
Okay. Well, I was gonna tell Jerry like do three.
If I had something, yes, it's probably
I was
excellent.
gonna send Eric down and have them text.
It's probably excellent.
Okay. Yeah, all right. Yeah, good.
They only want me to do
That's what I was gonna do. That boy.
Got it, dude.
Merry Crew count.
On the calculator. I'm dead.
I'm tired of guessing.
Yeah. Yeah. Hey Cam, they asked for you football players to be down in the library. Hopefully you'll be back soon, but we're gonna put a pause on. Go ahead and leave your stuff. They said just momentarily. Yeah, leave your stuff, just head on down there.